Turn the kitchen lights off. Turn the kitchen lights on. In this video, I'll be showing you how to build a voice remote for Home Assistant. And to be clear, I'm not going to be showing you how to set up Home Assistant. I'm not going to be showing you how to set up the voice assist in Home Assistant, and I'll be assuming that you have ESPHome installed on your Home Assistant server, because this does use an ESP32 board inside, and so we're going to be programming that with ESPHome. Now, one thing about this project, and part of the reason I wanted to do it is, Home Assistant now has voice assist, and it actually has a fully localized voice assistant system, meaning whenever it reads your voice and whenever it turns that into text and interacts with the system, and then it talks back to you, none of that runs through the internet. It's all local inside of the house. So you don't have to hit anybody's servers like Google or Amazon. Nobody's listening to you with that. So that's one of the great features about the Home Assistant voice assist setup that you can have. You can use cloud for it, but you don't have to. But in the Home Assistant kind of demo, they use this M5stack Echo kit, and those were out of stock for a while, and they don't run on battery. You actually have to have them plugged into a power source for them to work. So the advantage of this is that it's battery powered. You don't have to have it plugged in anything, and you can use a board that's in stock. I think that the M5 Echo kits are actually in stock again, and they are cheaper, but this is what I wanted. I wanted a actual remote. I didn't want something that had to be plugged in to work. So that's the benefit of using this build. So this video will also be arranged kind of in this order. I'm first going to show you the hardware and how to assemble the remote. And then I'll show you how to set up the software, the YAML code in ESPHome. And toward the end, I'll talk about some different hardware choices that I made. And, I know that whenever I show you what board I use, a lot of people will be like, hey, why didn't you use this or that? And I'll kind of leave all that discussion toward the end, because I just want to, for anybody who's just interested in getting a working battery-powered voice remote, I just want to go ahead and get them set up and underway. So with that said, let's take a look at some of the hardware that I used to assemble this remote. All right, so let's look at the hardware that we're going to be using for this project. So first up is the board that I'm going to be using, and this is an Adafruit Feather V2. So it's a ESP32 Pico chip. It's got built-in battery management, which is important for this project. It also has an onboard RGB NeoPixel, which I'm going to be using for a status LED. So I know immediately some people are going to be like, oh, why didn't you use XYZ board? I'll talk about why I chose this specific board toward the end of the video, because I just want to help people who want to just get something that works going. So I will come back and talk about why this board rather than something else later. So you also need a battery, and so this is just a 500 milliamp hour 3.7 volt battery. It's the one I chose. It's off of Amazon. Do note the polarity of the plug. I had to reverse these two wires because you don't want to burn up your board, and so just be careful to note the polarity that your battery is wired for and make sure that it matches the board. All right, next up is the DAC and amplifier. So this is a Max 98357A. It's an I2S amplifier, and so you've got your speaker wire outs, and then here are all the pins for the input. So a couple of things. Number one, you're going to be tying the gain pin to the ground pin, and that's going to set the gain at like 12 dB for this thing. The other thing is that I'm going to be using this SD pin. Now that is the shutdown pin, which is an enable pin for this amplifier. If you pull that low, it will turn this thing off and disable it. If you pull it high, it will enable it. It comes with this little bitty surface mount resistor tied between the SD pin and VN, which always enables this amplifier. But since I'm running on battery power, I'm going to be using the shutdown pin to be able to turn this thing off. And when it's off, it only pulls like 4 microamps. Now, the thing is, you don't actually need that resistor if you're going to be using the shutdown pin. And by removing that resistor, you can actually pull the current consumption of this thing whenever it's powered off down below a microamp. So I'm going to be removing that resistor. But do note, if you're not using the shutdown pin, you do need that resistor or else your amp won't be on. Next up, we'll need a microphone, and so this is a INMP441 microphone. Cheap, easy to get off of Amazon. It comes in a nice little circle shape. It's got 6 pins. There's actually, this also has an enable pin, but it is hidden. And the thing about that means that we can't turn this thing on and off by using its enable pin. But this has very low current consumption, so low in fact that, so we're going to tie the VDD straight to a GPIO output. So that means we can actually power this thing off or on by just pulling that GPIO pin high or low. Also, this little hole in the middle of what looks like it's on the bottom of the PCB, that's actually the input for the microphone. And so just make sure that you orient that toward whatever it is that you're trying to pick up. So let me add in something here real quick about these INMP microphones. And like one quirk with the ESP32 boards is they all have different modules. So there's like the older style, just plain old ESP32, and then there's the Pico version, and there's the C3, the S3, the S2. There's all these different like little versions of the ESP32. These microphones can be set to either output to the left channel or the right channel. And with the board that I'm using in this project, it needs to be pulled to the left channel. And so this LR pin needs to be tied to ground in order to do that. Now, in addition, you'll need a speaker. So this is just a little, like, I think it's a 14 by 20 or a 15 by 20 or something like that. Little speaker that I've got here. So this is the smallest speaker I could really find as far as a diaphragm magnet speaker. There are like some 30 millimeter wide versions also, but this is the one that I designed this enclosure for. You'll also need a button and a pull down resistor for the button. And so this is a button I got off Amazon, and this is just a 1 meg resistor that I'm going to be using as a pull down resistor. You can use different values for that resistor. That's just what I used. Lastly, for the enclosure, I've got this 3D printed enclosure that I designed. I will post up the STL, and I will even post up a step file for this. And it has basically a spot for the speaker to mount in. Right there, it's got another little spot for the microphone. And again, you want to orient that so that that hole at the bottom lines up, right there. So at the back end, you'll see another hole that lines up with the NeoPixel on this board. There's also a cutout for the USB and a little cutout to make sure that whenever this thing is oriented like this, that there's little room for the wires on the battery plug. On the bottom, you've got a spot for the button to kind of nest and a little tray for the battery to go in. And then you can route these wires down the side, and again, a little room for that jack to come out. And then once you've got all that in, you can pop the board right on top. And again, that little plug will come out, and then you can plug it in the side, and you'll have access to your USB-C. And it all fits in pretty good. Now, as far as the amp board, I'm just going to mount that in the bottom, and I'm probably going to double-sided tape or hot glue that in place. And one of the main reasons I'm going to be including the step file is just for the button mounting, because there's so many different types of buttons people may want to use. If you need to adjust the tolerance for the button, there's basically 2 ways you can do it. I've got a little nub in here that you can raise or lower, or this little platform that you can raise or lower. And that way you can get your tolerance set for your button. This button, I've got it set so there's just basically like a 1 millimeter gap in there. And then this, just flexes and pushes on that button, and then it just uses the button's own rebound to reset. And that's it for the hardware side. And so now we can get this thing wired up and test it out. Like I said, one of the first things I'm going to do is try to get this little resistor off. A little bitty guy. The first things I'm going to do is actually secure some of these components. And so they don't need much. I'm just going to put some hot glue, get the button in. All right, so after the button, I'm going to tack in place the ant board. Now, some people probably cringe at hot glue, but it works pretty darn well for certain types of things, and low profile is one of them. Okay, so that's the bottom taken care of. So now on the top, we're going to do something similar. Going to place in the mic, but I'm only going to tack at the edge on the microphone. Let's tack that into place. And this speaker actually has a bit of stick, so I'm going to use that, hold it in place, and just for a bit of extra security, lightly tack it in place as well. And so with those pieces in place, it's now time to start wiring. This is all pretty fine work in here, so I'm using a very fine solder on this project, and I'm going to start off just kind of tinning these holes. All right, so I've got all the components wired in. I did that first before I wire in the board just to keep everything a bit more manageable. I did tie some grounds together, and obviously I'm just doing point-to-point wiring in here because connectors don't really make a lot of sense in this context. I just don't have enough room for connectors everywhere in here. So now I'm going to move on to wiring in everything to the main board, and then we should be pretty much good to go. All right, so I've got everything wired in. Again, just doing point-to-point wiring. So at this point, I'm going to be fitting the battery below the board. Put it in there. I'm going to tuck these wires in along the edge here. There's enough room right there to get them in. Then bring in the board in. Once I get that, I'm going to plug. Make sure that everything stays tucked in. So I've got everything fit in there, but so just to tack everything kind of in place, just to make sure it doesn't move, I'm just going to lightly put just a bit of hot glue just in a couple of key places. Again, not much, just to kind of tack it down a bit. And this is more or less just to keep tolerances on everything whenever it all fits together. So there we are, all tacked into place. And now carefully, just so you don't pinch any wires, should fit all together. Let's do a little test. All right, that seems to work. All right, got the LED lit up. So now I've just got to put the screws in the bottom, and this thing will be ready to test out. Okay, so let's get the software set up and configured for your voice remote, and then you should have a functioning device. Now, I'm in Home Assistant, I am in ESPHome, and so as I mentioned previously, I am not going to be showing you how to set up Home Assistant or ESPHome or the voice assistant pipeline. There's plenty of tutorials that can help you with that. This is purely to get this device set up. So one thing to recognize is I'm in Chrome as a browser, and that is important because we're going to be using the web serial interface. And so if you're using Firefox or Brave or some other browser, this probably won't work. You do need to be in Chrome. So in ESPHome, we're going to click New Device, and your device does need to be plugged into the USB of your computer. So I'm going to name it Voice Remote. Pick whatever name you want. And then we're going to hit connect and find the serial port or COM port and hit connect. And so now it is going to set up the device, and this will take a couple of minutes. And so I'm going to cut the video and I'll be back whenever the device is finished setting up. Okay, and there it is. Our configuration has been created. Our installation is finished for now. So you hit close, and down here you'll see a notification because you've got a new device that Home Assistant's going to try to set up. But before you click on that, let's come in here and finish the configuration, because the initial setup just does a basic config. It just connects the device. We still have to configure everything for the voice remote. So you'll see that you've got your name up here, and this is where you want to open up that YAML file that you can download from my GitHub. And so in this, we're going to have to add some things. So below the name, we're going to cut this on boot and paste it in right there. And you'll see it gives us a little error on the sleep routine. Don't worry about that. That's just temporary before we get the rest of the code in. For the board, we're going to be changing that to the Adafruit Feather ESP32v2. This is not super important. It will actually probably still work completely fine with the basic board that it defaults to, but we're going to change that. And next, we're going to change some of the Wi-Fi settings so that the Wi-Fi connects quicker. Understand what I'm about to do, you don't have to do, but it can help wake the device up quicker from sleep. And so down here where it says Fast Connect On, Power Save Mode Light, and then the manual IP. We're going to come in here, drop those in, make sure you get them lined up correctly. And these are red because you do need to drop in your IP and gateway and subnet addresses from your network. It's best to configure your device with a static IP on your network, on your home network. It's not mandatory, but it really will help doing this fast connect mode to get the device connected to your Wi-Fi quickly once it comes out of sleep. So I'm not going to put in numbers for that. You can actually leave the manual IP out if you're not interested in having a static IP. It won't be a huge slowdown, but just know that that is an option in there. So I'm not going to worry about that right now because I don't want to go look up the IP address that this device is connected to. And from this point on, it's as simple as going back to the YAML file, coming below Captive Portal and just starting right here at Switch and just selecting everything to the bottom of the file, coming over here and pasting it in. And if you wire your device exactly as I have outlined in this schematic, everything should at this point just work because I've already got all the pin assignments in this YAML file set up exactly how they are on this schematic. So again, as long as you do this wiring correctly, there shouldn't be anything else left to configure. And that means at this point we can hit save. And since your device is connected, we're going to hit install. And at this point, you can actually do wireless because the initial setup in ESPHome should have already given the device your Wi-Fi on the network, but I'm going to go ahead and use it through the computer. And this is where you do have to be in Google Chrome or else this will not work because it's using a web serial interface that isn't available in a lot of browsers. So in the background, it's doing the compilation on your Home Assistant server. So this could take a bit depending on how powerful a device you're using for Home Assistant. But once again, I'll come back once this is done and we will finish up the configuration, get this thing integrated into Home Assistant and set up on your voice pipeline. Okay, so the configuration is now installed in the device. Again, I'm just going to save one more time before I get out of here. And now we can go down to this notification. Because now it's saying, hey, there's a new device discovered. We can check it out. And here you'll see voice remote in the upper left. I'll hit configure. It says discovered. Do you want to add? Yes, submit. And that's it. All right, the device is now in Home Assistant. Now we need to configure it for use with Voice Assistant. So in ESPHome, we're going to scroll down to Voice Remote, click on the device, and right now it's only got one entity set up, so we may need to give it a moment to make sure that it can find all of the entities on the device. Okay, and there it is. It does take a bit, so if you come in here immediately and you only see one entity, just give it a little bit of time. It just may be Home Assistant getting everything set up in the background. It did take like 30 seconds to a minute for all of the entities to populate into the device. But once we're there, you come down into configuration and make sure that it's set to Home Assistant if you want the local configuration. If you're going to use Home Assistant Cloud, you can flip it to cloud, but you want it set to Home Assistant for local. And at that point, the device should be completely set up, and you should, at this moment, assuming you've got all your wiring correct and have followed this tutorial, should have a working voice remote in Home Assistant. So I'm going to do a quick little demo, and you'll see in the logbook, right? So it says we're now on because I've woken the device up out of sleep. And if I push that button and hold it down, you'll see Remote Assist in progress. And if I let it go, you'll hear a little message.
Sorry, I couldn't understand that.
Because I didn't give it any commands. I've got the battery voltage sensor showing up under sensors. And by the way, you can use this for battery monitoring. You can set up little routines in Home Assistant to alert you in case the battery voltage drops below a certain point, such as, hey, you need to recharge this thing. So typically these types of 3.7 volt batteries are considered dead somewhere around 3.4 volts. So you could build that in, you could build in percentages and anything else you want, but at this point, you've got a working device, and that should finish you up if that's all you're interested in. So for anybody who's interested, I will show you a few different options in the code of this device in case you need to tweak anything. So at several points, you'll see the light turn on, and it will have a lot of details for the NeoPixel as far as its color and brightness. So if you want to change the color of any status condition, you can just adjust the RGB values here. And if you want to update the brightness, you can update that also. So if it's too bright or not bright enough, you can change that anytime you see that in the code. Do note that if you take the brightness below like 25% or so, you run into a chance that it'll just turn off altogether. So do be careful if you go below 25 and it doesn't come on. It's probably not because the NeoPixel's broken. You probably just need the brightness a little higher, or else it just doesn't come on. Other things, if you need to adjust the battery voltage, like if it's not reading exactly correct, because you can check it with a multimeter to make sure that you're getting the right reading. I've got an offset already built in here because I was using it earlier. And so you can adjust that trim up or down in case you need to adjust the voltage, in case the internal resistors on your board aren't quite perfect. That's where you can make that adjustment. Another thing is the update interval is 20 seconds, and that's partially why whenever this thing powers up, it stays on for at least 30 seconds. That makes sure that I at least get one good battery reading. But if you want to change that stuff, it's in the script at the bottom. So if I scroll down to the bottom, you'll see the sleep routine, and it's got a delay. That delay is how long the device stays awake before it goes back to sleep. So you do want to make that longer than your sensor read interval, just to make sure that you get, at least a good, sensor read or two. But if you want that longer or shorter, you can adjust that. And secondarily is how long do you want it to stay asleep before it wakes up? And the only reason I have it wake up at intervals is to make sure that that sensor gets read. And I've got it set to an hour. But if you only want it to check like once a day, just change that to 24 hours. So then it will, sleep for a whole day before it updates. Because the reality is, if you're using the remote, it's going to be updating that sensor, and so you really don't need it to wake up on its own that often. And so those are the options that are in here. There's a lot more if you understand the code, but those are the basic ones that you might realistically need, and those are the ones that I wanted to point out. So now let's actually look at the device and how this thing works. Okay, so let me show you how this thing then works. And I've got the status LED pulling off of the NeoPixel on the board, and you've got the mic input, you got the speaker output, and then you've just got your button up here. It's currently in a sleep state, and this thing will go to sleep after 30 seconds of inactivity. It then wakes up once an hour for 30 seconds, and mostly that is just to update Home Assistant on the status of the battery. So in here, it reads the battery voltage, and I've got that set up on a sensor, and then that outputs, again, it'll wake up once an hour, and just long enough basically to get a read off of the battery so that it can update Home Assistant. So to wake it up, you just push the button, and the orange light says that it's on, but there's no Wi-Fi. Once it turns blue, it has now connected to Wi-Fi. Now you hold the button down to activate voice assist. So if I push this and hold, the light turns bright green. That means that it is now reading my voice. Let go. It couldn't understand it because I didn't issue a command. If you ever get a red flash or red LED, that means that there's been an error in the voice assist pipeline. And let me see if I'll let this thing go to sleep. And sometimes if you trigger the voice assist too quickly, it will error because even though it might have, there it's gone to sleep. Even though it might have Wi-Fi, it hasn't yet established the API interface with the voice pipeline. So let me wake it up and see if I go, as soon as it hits Wi-Fi, I'll try to give it a voice command, and it should give me a red error blink. Wake up. Turn the, yeah, there you go. So you could see how it turned kind of orangish red there. That's the indication that there was some error trying to call the voice assist. It couldn't hit it yet. Now that it's been on a second, turn the kitchen lights off. I didn't pick up the signal there.
Sorry, I couldn't understand that.
Turn the kitchen light off.
Turn off lights.
Turn the kitchen light on.
Sorry, I couldn't understand that.
Turn the kitchen lights on. And that's really all there is to it. There's really no other feature or interface. It's just push the button and hold it. You do have to give it a bit of a delay after you push that button, or else I've found that it cuts off kind of the start of your phrase. And you do have to speak fairly clearly in order for the voice-to-text engine on the Home Assistant side to kind of pick up what you're doing. So that's the way it works. From this point on, I'll talk a little bit about the different hardware choices that I made when building this thing. You know, I've made those choices for some very clear reasons. So let me pull out the different boards because I tested this system with 4 different ESP32 boards to try to find the best version. And so let's talk through that because I'm sure some people probably are like, why did you use this instead of some other board? All right, so let's talk about, why I ended up going with an Adafruit Feather V2 in this project, because this was not my first choice board for this project. It also wasn't my second choice or my third choice. It's actually the 4th board that I picked to use, but it ended up being probably the best. There's one other that's not here because I found it after I kind of got this thing working. But let's get into this. So this is a basic ESP32 board. This is the dev board that basically ESPHome is really designed to work with. The issue with this is twofold. Number one, it's big. Number two, it does not have battery management. And so since this thing is designed not to be tethered, it does have a battery. I needed a board with battery management. So this just immediately wasn't a good choice for this project. Now, if you watched any of my other videos, you know that I've used these little Seed Studio JAWs in a couple projects. And this was actually my first choice, the Seed Studio JAW ESP32C3. And I got everything working with this thing, and you'll see why it's my first choice. It's so small, it's powerful enough, it would have done a great job. It's got, good Wi-Fi antenna here. But ESPHome, the audio output, uses some Arduino libraries in that process because this thing uses an I2S amplifier. And so it's got an I2S audio library that it's based on. And that library does not work with single-core ESP32 processors. The ESP32C3 is a single-core RISC-V processor. So I found out, almost getting finished with everything, but I just couldn't get the voice output to work. So this thing is out. I actually could get the voice output, but it was all kind of garbled and staticky. And so this just, okay, it's out. Next up, the ESP32 S3. So Seed actually makes a Xiao with the S3 processor, which is a dual-core processor. And I thought, this is the easy answer. Got everything working with this thing. But the problem was the Wi-Fi on this thing just sucked. It kept dropping out. It was very difficult to connect. When programming it, I constantly had problems programming this board. And so it wouldn't work, right? It wasn't consistent enough in the performance. The Wi-Fi was terrible. So yeah, the Seeds are both great. They've got the onboard battery management and all that, but this one wouldn't work, the audio pipeline. This one, the functionality of the Wi-Fi and the programming was just not good enough. So those two are out. Next up, I wanted to get back to the base ESP32 module because, again, that's the thing that everything in ESPHome kind of works with. And there's a board with that chip and battery management, and that is the Huzzah 32, the Adafruit Feather, basically the V1 version of this board. And so I got this thing all set up and working, and then found out that this thing pulls like 6 milliamps of power even in deep sleep. And with a 500 milliamp hour battery, that means that this thing's battery would die even if you don't use it within like 3 or 4 days. In my testing, this thing died after about 3 or 4 days, even if you don't use it, which to me just wasn't enough battery life. So on to iteration 4 with the version 2 board. Version 2 board pulls, I kid you not, less than 60 microamps whenever it's off. All right, so just a quick example of power use in this system, because I have mentioned that was one of my goals. So I'm going to set this thing to 4 volts. And there it's coming on. And there you can see as it connects to things. Let me see if I hit the button. You'll see that the power draw goes up to about 132 milliamps. And you can see it goes over 250 milliamps whenever the amp comes on. So now let's give it some time and it will go into a deep sleep state. And we'll watch the power draw whenever it goes into deep sleep. And there it is. It has now gone asleep. So let me move this over into microamps. There you go. Whenever it's in deep sleep state, under 30 microamps out of this thing. And again, that is the wired up system. Got it hooked in here, and that is at 4 volts. And that means that the battery life in the off state for this thing ought to be well over an order of magnitude better than the version 1 board. I haven't actually gone through an entire battery yet on this thing, but I'm guessing it should last for a month, if not multiple months, if you're not using it heavily. Now, again, we'll see, because under use, it uses way, way, way more battery, but all ESP32s use battery whenever they're on because the Wi-Fi takes power. The actual amp and the microphone don't really take much, but, whenever this thing's on, the LED's on, and whenever it's on, the Wi-Fi connects, that Wi-Fi is transmitting, and so this thing will use 250 milliamps of power draw under heavy load. So whenever it's playing audio and the LED's on and the Wi-Fi is connected, this thing will pull, 250 milliamps. So fortunately, you don't have to have it on very often, and it only stays in an on state for 30 seconds after each button press. So you can see it's already gone back into deep sleep. So that's how I've tried to maximize battery life, is by choosing a board that works well. Now, there's one other board that would probably work pretty well for this project, but I don't have one. I didn't find it until after I'd already ordered this V2, and that's the Tiny Pico. It's a very small board, so maybe it would be preferential to the Feather V2, but neither one of those are cheap. I think the Feather V2 is like 20 to 25 bucks. The Tiny Pico's in the same price range, so this is not the cheapest thing in the world. I really wish the ESP32C3 was better supported. by the audio library, because this would have been the perfect choice. They're cheap, they're small, they would have been enough to run this system, but that's an issue. So anyway, that's the roundup on why I chose this board. So the other thing that I'll say about this is the enclosure went through multiple iterations. I went through at least 2 complete ground up designs and then like 4 different iterations before I really got settled in this. It's still not perfect, but it's in a pretty good state. So I'm going to put up the STLs and step files for this. So you'll have the STLs if you just want to print it. And then there'll be step files if you want to modify it. All right, so that's going to finish up this video. I hope that you found it helpful. I know that, a lot of people are wanting a voice remote now that Home Assistant has voice assist in it, so that you can run a totally local voice assistant pipeline. All right, so if you've got any feedback, comments, questions, feel free to leave them down below. Otherwise, I appreciate your time.